Hey, good morning, Giants. And today is going to be our first lesson with this new hybrid model. So hopefully you can pull out your notes that you got at school yesterday. If for some reason you weren't there and you don't have them, send me an email. I can give you a blank copy of the notes that you can print off or fill in on your computer. Okay, and we'll try to get you guys all up to speed on that. So today we're going to be talking about distance. And you see our question here at the top of how do I find the distance between 2 points? Okay? So the first question is, what does distance mean? What is this? And I'm guessing most of you are familiar with this, okay? But distance is simply going to be how far, or length is another way to describe that. So we want to know how far two things are apart, or we could also say it's going to be the length of something. Okay. Now, in order to find that, there's something called our distance formula. And I'll write it out here to the left. Make sure to copy it down. This isn't something you have to memorize. However, you need to have access to it so you can use it, because we're going to use it throughout this chapter. But I'll start by just writing out the formula, and then we'll kind of examine what it means. So d equals the square root, and then we take the difference between x2 and x1, and we square that. And then we also take the difference between y2 and y1, so y2 minus y1, and we square that. And we'll add those two together, as you can see right here, with that plus sign, and then we'll take the square root. Okay. Obviously, I'm going to need to work on my skills, my handwriting on the computer. Give me some time. It's still early in the semester. I'm sure I'll get better at it. But if we look here at this first question, it says, find the distance between point 1, 3 and 5, 6 using the distance formula. Okay, so whatever we get as our final answer, that'll be D, or our distance. So we're going to start off now. We know that, let me change this to a different color. So D equals, and then we know it's going to be the square root. Okay, now up here we need to examine in our 1, 3. Hopefully you guys remember, but when we have coordinates, the x comes first and the y comes second. Okay, so 1 will be our x1, 3 will be our y1, and likewise 5 will be our x2, and 6 will be our y2. Okay, so now, if we look over here, we're going to take the difference between x2 and x1. So if we fill that in, 5 minus 1, I'm just going to put all that here for now, and then we're going to square that. Whatever we get there, we'll add to the difference between y2 and y1. So that's 6 minus 3. So 6 minus 3, and then we're going to square that. Okay, so now let's go to the next line. We know 5 minus 1 is 4. So it'll be the square root of 4 squared plus 6 minus 3 is going to give us 3. So 3 squared. Okay, we know 4 squared is 16 and 3 squared is 9. So 16 plus 9 here. 16 plus 9 gives us 25, so the square root of 25. And hopefully you guys know the square root of 25 is going to be 5. So right there, that is going to be our distance. Now, some of you might be saying, I thought the square root of 25 could also be negative 5. But something that we need to think about here. Oh, sorry about this. I'll authorize that later. Something we need to think about is, can a distance ever be a negative? And can we have a negative length? If I asked you how tall you are, would you say you were 6 foot or negative 6? And hopefully you know you're always going to be a positive. So a distance has to be a positive. So if it helps you, maybe over here put a little positive mark by that to remind you it has to be positive. And it doesn't mean how far or the length, but it has to be a positive answer. Okay, now what we did was the distance formula. The Pythagorean theorem now is what we're going to look at to kind of solve that same problem, the points 1, 3, and 5, 6. We're going to visualize it on a graph. I don't care if you always use the distance formula method or always use the Pythagorean theorem on a graph. As long as you are able to find the answer, you can do it either way. However, we need to know both of these methods, okay? So you know what I'm talking about. So the Pythagorean theorem deals with our triangle. So let's first plot these 2 points. So 1, 3 goes to the right 1 and up 3. Oops, that's not very good. Let me put it with my pen. Okay, 1, 3, and then over 5, up 6. And that'll be right there. Okay, so those are my 2 points. Now, when we are looking at this, if I draw in kind of a dotted line here, it forms a triangle. And more specifically, it forms a right triangle. Okay, now, if we have a right triangle, and we have one side is A, one side is B, one side is C. Pythagorean theorem, hopefully you remember this from geometry class, is going to be A squared plus B squared. All of that will add up to equal whatever C squared is. Okay, and in our case, that's still going to be the case. Now, C is the direct path here. C is always the longest side. It's also going to be the direct path in this case. We squared it off. So all we have to do is think about how far over does this go. 1, 2, 3, 4 is how far over, and then up 3. So if we treat this as our A, this is our B, it'd be like 4 squared plus 3 squared will equal whatever C is squared. Now 4 squared is 16 plus 9. Oh, I'm sorry guys, this is annoying. Equals C squared. Okay, so now the final thing we're going to do, we'll add those together and we'll get 25 equals C squared. And now we need to take the square root of both sides. So if I take the square root of 25 and C squared, I'm left with 5 equals C. We get the exact same answer, and that was how we solved it with the Pythagorean theorem and using our graph model. Okay, so if you want, you can try this one. Go ahead, pause the video, give it a try. I'm going to do it again, the same method. So we go to 10, negative 2. So all the way over, this is a 10 by 10 graph, and down 2. And then our other point is 7, 4. So we go over 7, up 4. Okay, and we have our 2 points. Now once again, once we have these 2 points, we can now draw in kind of our right triangle. It's not actually there, but we can visualize it, okay? And since it's on a grid line, it's always going to be nice straight lines that form the, as the vertical and the horizontal line that we draw will form a nice right angle for us, okay? So this comes down, and then it goes over, and then if you think about it, there's also that line. That is what we are interested in, that distance, okay? So from up here down, it's at 4, and it needs to get down to negative 2. That's going to have a distance of 6 on that one. And then over, we have a distance of 3. Okay, so those ones are easy to count because they the lines are straight. We can just count how many spaces it goes. The reason we can't just count this one is because it slants. I know my line's not straight, but it slants through here, and when a line slants across this grid, no longer allows us to accurately count it. Okay, however, from this point, we have our 2 different numbers right here, the 6 and the 3. So we can do a squared, so 6 squared plus 3 squared. And all of that added up will equal whatever C squared is. So 6 squared is 36. 3 squared is going to be 9. And that will all equal C squared. Now, some of you might be noticing that this one is not going to be a perfect square. So it's going to be a little bit more challenging, but we can still handle that. So this will be 45, which is going to equal to c squared. We still want to take the square root of both sides. Now the square root of 45, if you're forgetting how we can break that apart, what we need to do is first come up with two different factors that multiply to 45. So two numbers that multiply to 45, that's going to be 9 and 5. Okay. If you chose to use 3 and 15, that's fine. The only one you shouldn't probably use, 1 and 45, doesn't really get us anywhere. Okay. Now the 9 breaks apart to 3 times 3. Okay. So 3, 3, and 5, those are our three factors. Now the way I choose to do it, I like to circle my pairs. That pair is what comes out front. So we're going to have a 3 there. This 5 is lonely. It's all by itself. It has to stay inside. And we get 3 square root of 5 right here as what our answer is. Okay. So as we're doing this, if you ever have questions or you don't understand how I do it, the policies I want you kind of to do is first rewind it, maybe 30 seconds, a minute, see if you can understand it the second time you watch it. And if that doesn't work, then send me an email. Now I'm going to be teaching throughout the day, so I won't always be able to respond right away, but I will get back to you as quick as I can. Okay, so flip over your notes to the back side, and next we want to talk a little bit about how to use decimals and do some rounding. Okay, so first I'm going to write just kind of a general decimal, so 0.123. And I want us to talk a little bit about these different numbers. So the 1, hopefully you know this is your tenths place. If I ask you to round to the tenths place, I wanted you to stop after that one. Okay, now this 2, many of you hopefully know this. That's our hundredths place. And then finally this 3, let me draw that down so I can write it, is our thousandths place. All right, so now it says find the distance between the points P1 and P2, and then we're going to round to the nearest tenth place. Okay, so we're going to look at these first two. After we get our answer, we're going to look at these two decimals, and then we're going to want to round it. We'll talk about that in a little bit. Notice on this one, it didn't talk about rounding, so that's why we left it in radical form. If it tells us to round, though, then we need to solve it that way. Okay, so find the distance between points P1 and P2, and then round to the nearest tenth place. Now this one, if you want, you can take a look at a graph, you can graph them, and you can solve it that way. However, I'm going to solve it using the distance formula. Okay, so once again, if it helps you, label these x1, y1, x2, and y2. Okay, so now what we're going to do is set it up our distance formula. So d equals, you know it's going to be the square root. Okay, then we're going to do x2 minus x1. So -5 minus -3. So -5 minus -3. Square that. Add that with 2 minus -6, and we'll square that as well. Now, keep in mind, if it's minus minus, like here and here, if we subtract a negative, that's the same thing. You can think of that as adding. Okay, I kind of just put a plus on both of those to indicate to myself that what happened. Now, -5 plus 3 here, that's going to give us -2. That'll be squared. Okay, plus 2 plus 6, that'll give us an 8. Now, some of you might be thinking, I thought it was distance, it has to be positive, and you were correct. But that's the beauty of these squares. Once we square it, it'll take care of itself, because -2 right here times -2, that becomes a positive 4. So 4 plus, then over here, 8 squared is 64. And our answer here is the square root of 68. Now, it asks us to round our answer to the nearest tenth place. So open up your calculator. Here's mine. You can use it on your phone, the apps that we talked about in class. So we come up here and we want to use the square root. Remember, it's over here. I have to hit second to hit that. Second, and then the x squared button gives me that blue square root. Okay, I'll type in my 68, and then I hit enter. And here we get a decimal, 8.24, and it keeps going and going. However, we're rounding to the nearest 10th place. Okay, so all we care about is the 8.24. We don't care about anything after that. Now, the 4 is what's most important. Since it is less than 5, you round down, and our answer will be 8.2. Now, this is rounded, so we can put kind of a little squiggle equal sign. That shows it's roughly 8.2, okay? And that is our answer. All right, so let me make this calculator smaller, and then we've got one more problem here. It says find the length of the line segment that connects points A and B in the graph below, rounded to the nearest hundredth place. So we'll do the same thing we just did, except now we're rounding to the nearest hundredth place. Now this one, we didn't have the points initially. It's up to you. You can either find these coordinates and then solve using the distance formula, or we can draw in kind of our fake triangle, or it's a real triangle. It's just not there. We can visualize it though. Okay, so we kind of draw that in. All right, I'll get that fixed by the next video. But we draw that in, and now we need to think about what's the change in the height and the change in the width. So what are those two distances? So this one, it's down 1, 2, 3. That is 3. And over here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 3 on one side and 9 on the other. From this point, we can just use our Pythagorean theorem. So 3 squared plus 9 squared is going to equal c squared. Okay, so 3 squared gives us 9, plus 9 squared gives us 81, and that will equal c squared here. Now 9 plus 81 is 90, which equals c squared. At this point, we need to take the square root of both sides. That'll leave us just with c on that side. So we pull up our calculator, and since this is not a perfect square, I don't expect you to memorize this. Use your calculator, that's fine. Square root of 90. We hit enter. Now, on this one, it's important for us to be careful. 9.48, we do care about this 6 now because we're rounding to the nearest hundredths place. Now, hopefully you remember the hundredths place is 2 after the decimal. So this one, we can't just stop there. We have to look at the one after it to see what we're going to do. So 9.486, that 6 is above, or 5 or above, so we're going to go up. So 9.49. And that will be our answer for what c equals. And we kind of just made up the c. I guess I can label it right there. Technically, 9.49 is our answer for what the length is between A and B. Okay, so if you have any questions about what happened, send me an email or ask me the next time you see me. Let's not get too far behind. Don't wait a week or two to talk about this lesson, okay? It's going to be a strange semester in that you're not going to see me every day, but we can still communicate, okay? So I hope you guys have a great rest of the day. Make sure to do the small kind of review activity I got for you, and I'll talk to you guys later. Have a great day.